The other trigonometric functions. For a while now, all I've done is talk about sine and cosine. I've talked about how to evaluate them. I've talked about reference angles. I've talked about how to graph them. I've spent a good amount of time with those two functions. And now that we have a good idea of most of the stuff that's going on with sine and cosine, I'm going to go back to the other four functions. Okay, there's tangent and then all the reciprocals, cotangent, secant, and cosecant. Okay, I'm going to revisit those and now go ahead and define them. Okay, and once we have definitions of them, we can start to evaluate and we can start to graph and we can start to do all the same things that we did with the sine and cosine functions. What you can see here is a similar diagram to the one that I used when I first introduced the sine and cosine definitions in terms of x and y. Okay, the only difference with this diagram versus that one is previously I had the terminal ray in the first quadrant. For this, I just actually have it in the second quadrant. But overall, that doesn't really make much of a difference. And we saw that when we started looking at reference angles. All right, so I'm going to go ahead and add in here the components. I'm going to add in here the components that go at this point. Okay, so you have an x component, you also have a y component that would go there. All right, now technically this is a negative x value, but for the sake of writing the definitions of these, we're not going to really worry about the positive versus a negative right now. In a bit, we will talk about that. If you recall tangent from right triangle trigonometry, it was defined as being the opposite over the adjacent. That would be the side opposite of theta divided by the side adjacent to it. Okay, and what we had learned with reference angles is that if you have theta that rotates all the way out here, you can essentially just treat this angle right there, which is the reference angle to it, you can treat that as if it were the theta, and you still get the same calculations just depending on the signs. That would be the only thing difference whether it's positive or negative. Okay, so we're going to treat that as our theta, even though this is it. We're going to treat that as our theta as we write these definitions. So tangent is the opposite over adjacent. Opposite of that angle is the y value. Okay, so we're going to have the y value divided by the side adjacent to this, which would be x. All right, so our definition in terms of x's and y's for the tangent of a theta is actually going to be y divided by x. The cotangent is the reciprocal to the tangent. That means that you could just call it x over y. That's how you would evaluate the cotangent of an angle. Secant is the reciprocal of cosine. Okay, and remember that cosine is the x over the r value. So that means that secant is going to be the r value, the radius, divided by x. And cosecant is the reciprocal of sine. The definition of sine was the y value divided by the radius, so reciprocal of that will be the radius divided by the y. All right, so now we have definitions to all 6 trig functions. As mentioned before, the quadrant that you end up in is important, right? If you're in the second quadrant, you get negative x values and positive y values. If you're in quadrant 3, they're both going to be negative, and quadrant 4 would be positive x's and negative y. So all that is important. The neat thing is that the sine and cosecant are actually reciprocals of each other. They're just the same values flipped over. So any quadrant that sine is going to be positive in, the cosecant is also going to be positive in that one. There's no reason for it to change. It isn't. They're just reciprocals. Reciprocals don't change signs. Okay, so let's think about this. The sine is positive in the top quadrants because those are the locations where y values are positive. That would be quadrant 1 and 2. Okay, so even the cosecant is going to be positive there. The bottom 2 quadrants, 3 and 4, is where sine is negative. That means that if you evaluate cosecant for an angle in quadrant 3 or 4, you'd get back a negative answer. Now, cosine and secant, those are reciprocals, so we can really just look at cosine. Cosine is positive to the right. That was in quadrant 1 and also quadrant 4. It was negative to the left, which are these. So secant will also be positive in the first and fourth, negative in the second and third. Tangent. We haven't talked about this one, have we? Okay, so tangent and cotangent. They're going to be the same because they're reciprocals. Okay, now we got to think of the definition here. Tangent is the y value divided by the x. Cotangent is, of course, the reciprocal, so we'll focus our attention on tangent. Here, let's go ahead and draw a little circle here just for reference sake. Okay, x's and y's. We don't get to just look at one and then, assume that it's got a radius that's positive. We got to look at both of them. In quadrant 1, the x's and the y's are both positive. They're both positive, so no reason to assume it would become negative. That's going to be a positive. In quadrant 2, you get negative x's but positive y's. So if you have a positive number divided by a negative number, you get a negative. Quadrant 3, you have negative x's and negative y's. If both of these are negatives, they're going to cancel out and give you a positive. Quadrant 4, positive x's, negative y's. You have a mismatch. That would give you a negative. All right, example number 1. Let's see if we can evaluate some things here. Okay, what we're going to need to be able to do here is make the connections between reciprocals. What we have here is secant, cosecant, secant, so we need to know what their reciprocals are. We are also going to be looking at the special angle measurements. If you notice here, it's 60 degrees, 150. 150 is based off of those special angles, and even 5 pi over 4. That's going to be based off of one of our special angles here. Okay, so here's how I would take you through the problem. We don't want to just type these into the calculator. That's kind of the point here, is we don't need to do that with any of our special angle measurements, and you want to be able to evaluate these without needing that step. And on some calculators, you don't even have a button for these reciprocal functions here. Okay, so here's what we're going to start with. We're going to think about the reciprocal. The reciprocal of secant is cosine. Okay, so I'm going to write this down. We're going to think cosine 60. That's what we're going to do. We're going to think about the cosine of 60. And we know what that is. The cosine of 60 is equal to 1/2. Now, if the cosine is the reciprocal of secant, we can actually just flip this answer over. We can say that the secant of 60 is equal to 2. And that's it. That's the answer. Unfortunately, if you don't have a calculator that you can just type secant into, which I don't, this type of calculator doesn't have a button for that. I just have sine, cosine, tangent. You can't really evaluate it and test it. Now, the one thing that I could do, though it should seem fairly obvious when I check this out, I can take the reciprocal of cosine to type it in, so I can do 1 divided by the cosine of 60. Now, before I press enter, I'm gonna switch that mode, because that would not work out. I need to be in degrees for this one. Okay, so I can at least type it that way. You can see that it evaluates it too. But it does it because of this, because it understands that the cosine of 60 is 1/2, and then that flips it over and gives me 2. All right, cosecant 150. We're going to think about the reciprocal. We're going to think about sine, the sine of 150. All right, now this one's going to be a little bit more interesting because we're moving outside of quadrant 1. Okay, quick sketch is pretty good too. Okay, we're out of quadrant 1. 150 is going to be in quadrant 2. It's going to be over there. But more importantly, how far is it from the x-axis? That is, what is the reference angle? Okay, the reference angle would be 30 degrees. The distance from 180 to 150 would be 30 degrees. Okay, so I start by thinking, the sine of 150. But now I got to think the sine of 30. Okay, and then the sine of 30, coincidentally to the other problem, is actually 1/2. Sine of 30 is equal to 1/2. Okay, so I don't want that answer though. I want a cosecant. So this answer is going to have to flip. We're going to have to flip that answer over. The cosecant of 150 degrees is going to be the 1/2 flipped over, which is 2. Okay, and there's one other thing that we would need to check. It doesn't change anything in this problem, but we would want to check it, is that we have moved out of quadrant 1. We've moved out of quadrant 1 and we're in quadrant 2. Is that a positive or negative quadrant for sine and cosecant? Well, the top 2 quadrants are going to be positive. So our answer is going to be 2. Go ahead and box that one also. All right, last, let's take a look at a radian problem here. The secant of 5 pi over 4. Okay, so we're going to think about it first as the cosine, because that's the reciprocal, the cosine of 5 pi over 4. In addition to that, I'm going to go ahead and make a picture here, because that is also out of quadrant 1. 5/4 pi, well, pi is going to get you here, that'd be 4/4. So you have an extra 1/4 of a pi. That's going to place you right here, right between those two diagonally. Okay, so we're over here. The space from here to there is going to be 1/4 of a pi. That would be the same thing as 45 degrees. Okay, and the cosine of 45 degrees, or the cosine of pi over 4, is equal to the square root of 2 over 2. So, the secant of 5 pi over 4 would be equal to the reciprocal of this, 2 over square root 2. And we got to check our quadrant. We're over here in quadrant 3. For cosine, these two quadrants, 2 and 3, are actually negative numbers. So it would be a negative 2 divided by square root 2. Now, that answer is not going to cut it because we ended up with a radical on the bottom. We're going to fix that up by multiplying the top and bottom by square root 2. And that will give us negative 2 square root 2 over a regular 2. Regular 2's can cancel out. And we end up with negative square root 2. That'd be the answer. Not a lot of space to squeeze that in there, but that is it. The secant of 5 pi over 4 will be negative square root 2. Example 2. If theta is a second quadrant angle and tangent theta is equal to negative 3/4, find the values of the other 5 trigonometric functions. Okay, so I went ahead and drew an x-axis and a y-axis, and I'm going to go ahead and make a circle around that. All right, now theta. We don't know the measurement of theta. We don't know that. But it does end up in the second quadrant. It ends up over here, okay? And if we were to evaluate theta, if we were to evaluate it, we would get negative 3/4. Okay, let's think about the definition of tangent first. The tangent of theta is equal to the y value divided by the x value. It's equal to the y value divided by the x value. We got a 3 on top of a 4. That means that the y value is going to be the 3 and the 4 is going to be the x value here. All right, so I can imagine moving out. We'd have to go out 4 and then up 3. So it's going to be a little bit further out than it is up. It's going to, well, I'm going to put it there. That's going to be a little bit of an estimate, but I know it's a little bit further out than it is in the up direction. Okay, so this will be a 4. That will be a 3, and because I know I'm going to need this, I'm going to go ahead and add in here a radius. And the value of that radius, I hope you can recognize. This is a triple here, Pythagorean triple. That would be a 5. But if you needed to, you could do 3 squared plus 4 squared. Figure out that it is going to be 5. All right, there's one other thing here. That negative that we have. Okay, so that negative either needs to go to the 3 or the 4. It can't go to both of them. If it went to both of them, it would have canceled out. Okay, so it either goes to the 3 or the 4. Because we're in quadrant 2, it's going to go to the x value, that left movement that we have. Okay, so we actually have a negative 4, we got a positive 3, and then the radius, we always treat that as a positive. All right, now with all that labeled, we should be able to evaluate the other trig functions. Okay, so we already got tangent. Cotangent, we can knock that one out real quick. That is just the reciprocal of tangent, so that's negative 4/3. Really easy one there. All right, next, we're going to look at sine theta. Let's go ahead and do cosine theta. We'll do those two back to back. Sine theta is going to be the y value divided by the r, or the radius, so that would be 3/5. Cosine is going to be x over r. that would give you negative 4/5. We'd get that. And then the reciprocals. All right, the reciprocal to sine is cosecant, which means that that answer will be 5/3. The reciprocal to cosine is secant, so that will be negative 5/4. I'm going to add in one more thing to this video, which is the graph of tangents. But when I do it, I'm actually going to cheat a little bit here. When I looked at the sine and cosine graphs, those I really focused on taking individual points and connecting them and making the graphs, which takes a little while to do. The tangent function is a little bit harder to do those things with. We end up being a little bit limited on the coordinates that we can actually plot and how they look. So we're going to cheat just a little bit here. What I'm going to do is start with an actual picture of it. I'm going to go ahead and graph it. Okay, so I'm going to put in here the tangent of x. Type in the tangent of x and let's see what it looks like. Okay, it's a different looking graph, isn't it? When you saw a graph, you would see it wave as it went up. All right, all of these gaps that we have between these little curves, those are actually asymptotes. The graph continues up forever and is approaching a certain value, never actually reaches it. Then it's like it kind of picks up on the bottom, super close to that same line, and then starts to veer away from it and then go towards another line. These are asymptotes. They're little boundaries in the graph that the tangent function just doesn't exist at. All right, so now that we have an idea what the graph looks like, let's go ahead and start to plot a couple of the points. So let's think about the definition of tangent. The tangent is the y value divided by the x value. It's always going to be the y divided by the x. Okay, so what I did is I chose certain angle measurements that we'd be able to compare the y and the x values from. And we should get enough from those angles that we can tell it matches the picture that we see in the calculator. All right, so at 0 degrees, you know what would help? I'm going to go ahead and draw one of these circles again. All right, so we'd have points that would be anywhere along that circle, which would have x and y coordinates. Okay, at 0 degrees, which would be right here, at that spot, you'd have a value for x that you had to go out, but your y value is a 0 because you're not up or down compared to the x-axis. Okay, so at that spot, you would end up with 0 over x. That means that you would get 0, and 0 divided by x is 0. Okay, so we're going to get a point here. Let's go ahead and jump to this spot here, pi over 2. That'd be right up here at 90 degrees. Over there, you get the exact opposite case. Okay, at this location, you have all y value, but your x is 0. Now, the problem with that is that tangent is defined by taking the y value and dividing by x. And if your x is 0, and you try and divide y by 0, or any number by 0, you come back with undefined. And that's how we get these asymptotes. These asymptotes are going to exist at all the different places where the x value is a 0. All right, so at pi over 2, what I'm going to do is put in a little dashed line. That's an asymptote. Okay, that's going to happen there. In between those two values, pi over 4, that would be at 45 degrees. That's right. Here, at that location, here, the x value and the y value are actually the same. That's how you'd end up on that perfect diagonal. You would have the same x and the same y. So whatever those values are, if you divide them, and they're the same thing, you're going to get 1. Okay, so pi over 4, you get 1, or you could also think of it as 45 degrees, you're going to get 1. All right, the way that I have this broken up here, that would actually fall right between these two. So between those two, I'm going to put a dot right there. All right, and now I think the rest of these, if we're just thinking about the fraction, we can actually start to fill them in pretty quickly here. All right, at this spot right there, which would match up to right between these two little dashes, at that spot, the x and the y values will have the same absolute value, except that you're going to have a negative x and a positive y. So instead of plotting at a 1, have to plot that at -1. All right, and then when we get to pi, or 180 degrees, at that spot, it's the same situation that you had over here. You're completely x, you got no y value. That means that you're gonna have 0 divided by x, you get 0, you get that. Moving around at that spot, the x and the y values will be the same, and they're both gonna be negative, -x and -y, which means that when they divide out, you get a +1, so you get a dot there. And then when you get to this location, when you're here, your all y value, no x value, so you're dividing something by 0, you are now undefined again. We get another asymptote. All right, now, for the sake of not spending too long plotting points, you'll be able to start to recognize the shape. Now that I got two asymptotes, we can sort of see that. The graph, and this asymptote right here is right there in the picture. It's right at that spot. The graph will be next to it to the right on the bottom. It's going to give this sort of curved shape through that area and get close to the next asymptote. Okay, and you can already see part of that shape over here. And let's see. The next asymptote that we'll get over here will be located at -pi/2. You'll then have one here. That's fine. And you can make as many of these as you feel you need. All right, that is the tangent graph.
Wait, what?